So we have about 30 minutes to talk about 3D printing, and I guess we're summarizing what we want to talk about. It comes down to, is it hype or reality? That's what we're going to try and solve. Quick rundown of the panel. I purposely try to get people that could represent three different aspects: the consumer 3D printing world, the industrial, and the medical. So Bram, who's actually the CEO and founder of 3D Hubs, the largest network for 3D printers across the globe. Jack, who's actually Dr. Jack Reindler, who is not only a physician, but also an investor in health-related startups. Andy, who's actually the founder of Fab Lab London, he calls it Tony Stark's personal playground inside the city, 4,000 square feet of manufacturing goodness. And Tom from Print to Peer, who actually just completed Techstars in this last batch here in London and is doing some pretty cool stuff around software layers on top of 3D printing. So what I'm going to do is just walk through a couple of visual slides first on stuff that's actually possible today around 3D printing. And then we'll switch it from that to actually getting their expert insight into what's reality, what's hype, and what the future looks like. So this is actually a quote from Forbes earlier this year. You can pretty much Google the words 3D printing changing the world, and you'll get some ridiculous quote about how this is the biggest change to the world since Industrial Revolution, to the way in which you could produce, consume, and share products. I'd argue some of that might be ambitious, some of it is actually true, and today we're going to try to separate a bit between both of us. But what actually is possible today? So a couple of examples of stuff that you can literally 3D print today, either in your own home 3D printer or through an industrial partner. Everything from like electric guitars or actually musical instruments that are fully functioning to pieces of guns that are actually illegal for you to buy in a store, but you can actually get 3D printed at your house, to bridges. There's actually in Amsterdam where you can actually watch a bridge being built live by a 3D printing robot. To a house in China where they actually have this neighborhoods being built by gigantic 3D printers that actually can produce the house. I think it's in less than half a day, right? So the idea of actually you living in something that gets printed almost immediately. We were talking earlier on about in refugee crisis where you could actually 3D print a medical facility on the spot as needed. To in the medical world, where you're literally seeing things from prosthetics to actually, if you're actually missing part of your skull or needs to be replaced, you can actually build it, to actually rib cages made out of titanium specifically for your body. This is actually all reality today. To actually one of my favorite initiatives, this is an open source initiative to build 3D printed hands, which are being crowdsourced and actually very low cost and being distributed out in emerging markets. It's openhand.org is the website. To food. You can actually go through, there's a 3D printing exhibition here, and you could book yourself into the restaurant and literally eat mushrooms that were growing out of these 3D printed things. I tried those. Or 3D printed burgers, which actually comes out of 3D printed meats. I did not try that. 3D printed chocolates, 3D printed pizzas. All actually being made through this machine that reminds me a lot of like the Star Trek Recombinator. So what I wanted to get back to the panel with was kind of these four questions. Is this actually on the cusp of going mainstream? Is it really being democratized in the way that some of the press actually makes it out to be? Will it revolutionize factories? Is it already revolutionizing factories today? Will it revolutionize medicine as we know it? And actually, is that Star Trek Recombinator actually a reality? And will it be in the next 5 to 10 years? So with that, let me switch over to the panel and maybe start with Bram, maybe Andy, on the consumer aspect of it. There are hundreds of thousands of 3D printers, desktop 3D printers today. You actually map a fair amount of them through your network. How close are we to this democratization of 3D printing in our homes?
Yeah, I think today there's indeed around 500,000 printers out there. Over the last 4 years, the number of printer sales has doubled every year. So it's really taking off. 3D printing has actually been around since the 1980s. Most people don't know that. They were hidden in factories. They were large industrial machines costing up to $1 million. But those trend over the last few years that you could just put a printer on your desktop has really made it more popular to consumers. I think it's very cool that anyone with an idea can now just design it in open source design software and then just print it in their home or through a network very easily. So it does help for people with ideas to bring their products to the market, both on the prototyping level, so to make a model before you actually take it into mass production, as well as for actual end products. We see that more and more. For example, with our network, we've produced 7,000 smartphone cases for the Fairphone brand over the last year across 300 of our locations. So it is also on desktop level being used more and more for end products.
But is it democratized to the point where I, as an average dad in North London, would actually buy one for my home today, or do you still see it as fairly niche for geeky people like us?
Well, they start to become cheaper, so they're now around $500. I think one of the first applications we'll see in the home is more for children. I just got my first child, and I think it will be very fun for her when she grows up, that she can design her own toys instead of something that was designed for her. So I think it really can help her become more creative. So I think that's one of the first applications you see in the home. I don't think it's likely that all the products that we use daily will be produced at home. Most likely you will need larger industrial machines in a network, for example, through 3D hubs, to get that made. Yeah.
And Fab Lab's actually one of the hubs, one of the network members for 3D hubs in London. But you guys also do some educational stuff. You actually supply digital designers for building stuff. I mean, we were joking earlier on that a lot of things that actually get created and passed onto your network never get picked up.
Yeah, I mean, from our experience, we're seeing that, the question is it mainstream? I think it is already mainstream, and that you were saying earlier that the parts in Audi cars have been 3D printed, or that some of the Airbus parts are printed using 3D technology. I think the democratization aspect, we're yet to see, as ubiquitous as a microwave is in the kitchen, you're not going to see the 3D printer in the kitchen. And to me, the 3D printer is kind of microwave of the technology at this moment in time. So I think there's going to be a bit of a gap between seeing these in your every home across the country, mainly because of cost and resolution and time to print. Things take so slow, very slow to print. So there's a hurdle to overcome from a kind of educational perspective before you see these in the house, I guess.
But today, like people that actually come to Fab Lab to produce stuff, what's the profile? Are these designers trying to fast iterate on prototypes?
We see people from 8 to 80 in the lab, literally 8, 9, 10-year-olds printing their little robots. The question there is, are you creating more waste? Because obviously these robots don't go anywhere apart from into a recycling bin, which obviously Bram could recycle as part of some of his hubs. Then we see the 40, 50, 60-year-olds who come in with traditional skills, so kind of milling and lathe skills from the kind of 50s and 60s. And they're seeing new ways of using the technology to prototype almost like a one-off product for their need. The example is one of our colleagues in the lab, his mother has got arthritis, and he actually scanned and produced a bespoke walking stick for her using 3D printing. That's one of the real benefits of technology. You can produce one solution for one individual, not mass market approach of 10 million widgets for the 10 million people, which usually there's a little bit of variance in their needs.
Yep. So talking a bit about the industrial side, one of the most amazing things I ever saw was the Red Bull factory outside of London, where literally every day they produce, I think, 4 or 5 different models of the Red Bull car at scale to put into the wind tunnel. And they have, I think, 30, 40 industrial printers just printing out different versions of the car. But as you said, it's actually been mainstream in the industrial world for a while. A lot of what you're trying to solve is actually some of the challenges for it to really go mainstream in the industrial world. So what do you see from your client's perspective? What's happening today, and what's actually limiting a broad adoption of 3D printing across factory floors?
Yeah, so it has been around for 30 years. So we've seen 2/3 of the top manufacturers are already using 3D printing. So they are currently scaling up their 3D printing resources to not just build prototypes, but actually end-use production parts on some of these cars. Not just at F1 companies like Red Bull and McLaren, but also in sailing teams, and even at GE for aircraft parts. But yeah, the fact that they are scaling up their resources means that they've got big fleets of 3D printers, but they currently don't have a way to manage these 3D printers. So when they buy more machines, they have to actually hire more people to manage them. So what we're trying to do is actually come in and provide this software layer that actually manages all the 3D printers for them, so that they can scale up their 3D printing resources.
Yeah, but you're also doing some stuff with 3D hubs on the industrial side as well, right? I think, and it actually, I didn't know until recently the type of materials you can actually build with now. I mean, platinum, titanium, gold, silver, and actually you can effectively lease printer space from industrial producers to actually go manufacture these devices. Give me some examples of some of the cool stuff you're seeing on both of you guys on the industrial space. I mean, yes, pieces of my Airbus or pieces of the Audi that I drive day to day, but what other stuff would we not know is actually as mainstream as it actually is?
Yeah, I think what Airbus is doing is very cool. So their latest plane has over 1,000 titanium and aluminium 3D printed parts in it, and they're able to save 55% weight on those parts because of the design freedom that 3D printing gives you. And because with 3D printing, products are made layer by layer instead of inside a mold. You have a lot more design freedom, so you can make more lightweight products. And in a plane, that's especially important. I heard that every kilogram of weight reduction saves around $5,000 in fuel over the lifetime of a plane. So there, 3D printing is a very economical manufacturing method.
And along the same lines, GE has a fuel nozzle that goes into every single one of their jet engines. And it used to be made out of 21 different components that each needed to be manufactured and then assembled together. Well, they figured out how to 3D print it in one part. So it's actually a more simple part overall, which actually saves material and cost. But they can actually make these directly from a 3D printer, so they don't need inventory anymore. So they're just printing thousands of these new fuel nozzles.
I think it was Utah was telling me this stat that on a per capita basis, Europe is actually significantly ahead in terms of penetration of industrial 3D printers.
Yeah, we're seeing a lot more 3D printing usage here than in North America. I think it's like the UK alone has so many engine manufacturers themselves. Like even the F1 companies, like if you have a faster engine and you can get it to market faster, then you have a competitive advantage against your competitors. So I think it's definitely one of the biggest technologies that people are looking into right now. And 3D printing, it also doesn't exist in a bubble. I think the technology itself isn't going to, they're not going to be replacing all of their manufacturing with 3D printing, but it's complementing the existing technologies that they have.
Yeah. And what's the deal in Belgium and the Netherlands? Why there's so many 3D printing startups and actually fairly large companies as well? Is there like a history behind it?
Yeah, it's a good question. Maybe it has to do with the fact, with the company where I started my career, it was basically the first company in the world that's used 3D printing to create consumer products. The company was called Freedom of Creation, and they started back in the year 1999, which is a long time ago, thinking about a future where products are no longer made on the other side of the planet in huge quantities, but instead, with 3D printing, we can ultimately create a future where products are made local and on demand. So you have no more overproduction and long distance transportation. That vision intrigued me so much that I decided to stop my design career and go into 3D printing. Yeah, so I only joined them in 2009, so I can't take all the credit. But I think they did inspire a lot of people and companies within the Netherlands and Belgium to get into 3D printing, yeah.
Yeah, actually, if you look at the map on your own website and you look at the concentration of 3D printers, actually Northern Europe seems to have a surprisingly high number of machines. Although I'm from a small country of El Salvador, and you actually have 2 printers in El Salvador on your network. So I was thank you for that.
Cool.
The medical side, Jack, is actually fascinating. We were talking about it earlier, right? And I think there's a lot of stuff happening today that many people might not know about. Yeah, the printed ear, or actually like 3D printing even genes, it's happening today. But we were talking about how the challenge is from that to actually your physician recommending a 3D printed treatment, let's call it, is still fairly far away. Like, you get to see a fairly broad stuff and innovation around the medical space. Like some of the stuff that you're seeing today around 3D printing that gets you excited, and where do you think it might go down the road?
Yeah, I think the interesting thing about this kind of rapid personalized prototyping and design, which 3D printing allows you to do, is that it kind of it meets the precision medicine world. And I think the reality is that, you know, the average physician, let alone the really kind of technologically advanced physician or surgeon or whatever, is probably not even aware of these things happening. You know, for them, manufacture is something that is done by an approved brand that, you know, produces one thing that has been tried and tested and fits all. For instance, maybe like a hip replacement. And as soon as you start getting into kind of, this is a hip replacement which we have 3D printed for you, it starts to become, oh, well, you know, where do I get the warranty from? Who's gonna fix it when it goes wrong? And there's lots of these kind of regulatory barriers that I think exist, which kind of are presenting, in my view, a barrier to the adoption of a lot of these things. However, we're seeing some very cool stuff. So, for instance, I mean, you know, our very own Great Ormond Street, for instance, was one of the real kind of pioneering centers which showed what 3D printing could do. It was it was just over 5 years ago now that the medical director of Great Ormond Street, Professor Martin Elliott, saved a young child's life by 3D printing human lung collagen matrix at UCL, bathing it in stem cells and reimplanting that, you know, fabricated human lung tissue into a child whose lung tissue was collapsing and would have meant certain death for the child, and that saved that child's life. So stuff is really happening. We're seeing printed tissue, especially of the same vein, like collagen matrix, ears, skin, pieces of bone, stuff that's removed from people's bodies, big cancer operations, parts of people's jaws being 3D printed, put into human beings, and obviously there's the whole sort of stem cell stuff on top of that. It is happening, but it's very, very slow. If you're the right kind of patient in the right kind of center of excellence, you may be a beneficiary. Right now, today, I don't think there's a 3D printer in any GP that you'll ever go to. And certainly not even in the most advanced centers will you see it sort of completely broad spread. And I think the answer to seeing adoption in that space is education. It takes very, very innovative pioneers to actually get 3D printing into their institutions. We need to start introducing rapid prototyping, 3D printing, personalized manufacturing, and start introducing that into education so that the physicians, the surgeons, in 15 years' time will be familiar with this kind of technology. And so, I think one of the key things is to start pushing this to get into medical school, and then we'll start seeing adoption.
But there's still a regulatory hurdle of, you said, like, if I get a hip replacement that's 3D printed, that has to be FDA approved or whatever. And by the way, if it breaks, who do I call? It's not MakerBot.
Yeah.
So I think who drives that? Is it pharmaceutical companies or actually companies that currently make hip replacements?
Well, let's take a really interesting example of something that I think would make potentially a very significant difference to people's lives. There are people like HeartFlow in the States that are doing computed tomography from scans to look at arteries that are narrowing, and computing through fluid dynamics the areas of your arterial system that may need a stent, and then suggesting exactly the right kind of shape of stent that you need as opposed to the standard one that you get issued. So 3D printing personalized stents to make ideal changes in the fluid dynamics, the flow of blood through your arteries. If we're going to optimize people's outcomes in significantly large-scale problems like coronary vascular disease, by doing personalized therapies like this, who is going to end up doing the research to prove that that is better than the standard stent? Where is the economics of it? Is it going to come from vanguard institutions like the Mayo, UCL, etc., or is it going to come from the manufacturers themselves, who there is kind of maybe a conflict of interest between producing mass-scale stuff that fits everybody versus something that gets you better outcomes but costs an awful lot more to produce potentially. So I think it's going to be a challenge, and it's going to boil down essentially to the economics. I certainly would be pretty scared to 3D print a stent for my patient, and take on all the warranties, etc.
And liabilities too.
And so it's really going to boil down to the economics. Who's going to make the money out of doing this stuff on a personalized level?
Yeah, and the other example that's been touted in terms of 3D printing for medicine is literally like the MakerBot in your house printing medicine for you based on the way that your cells react to different types of medicine and molecular compounds. Is that 5, 10 years away?
Yeah. Well, I think what may happen before we actually start printing sequences of proteins, for instance, as personalized medicine, is at least creating personalized pills that change in dose according to whatever effect is happening on your body. And I do actually see a slow move, but a significant one towards having dispensaries at home that effectively print from reservoirs of substrates the exact combination of medicine in a sort of computed dosimetry form for you to take. That I don't think is necessarily a decade away. Actually printing personalized medicines for you, I think, is beyond the 2025 timeline.
I mean, we started talking a bit about the future on the medical side, but let's go back maybe to the consumer side and talk about, you guys obviously live, breathe 3D printing and evangelizing it all the time, but what do you think the future holds, let's say, 10 years down the road in terms of what you and I will have access to?
I think I was born in the late 60s, and I remember the birth of the personal computer age back in 82, 83, when you have the BBC Micro, the Spectrum, and I saw that age grow. I've seen the internet come, mobile phones, and I'm seeing now this almost like a similar point with rapid prototyping. There's a point at which there'll be a lot of tinkering with like the kind of hackers, the geeks, the open source community to try and take the printers beyond their current form. The ones I'm used to are kind of desktop ones that can prototype, a part for your car, fix your toaster. We can print a shoe. We can do some microphones. We can do, your cufflinks, all that kind of stuff. It's when you give it to the 11, 12, 13-year-olds, give them 5 years. They're so far ahead of you already with the kind of the millennium, the Googles, the way they think. I think, from my perspective, my experience, I think we're going to see a lot of quick change over the next 5, 10 years where these become part of the fabric of a younger generation. So it'll become part of this kind of school as a de facto. There'll be kits you can buy, and there already are kits you can buy now off the shelf for £300-400, even less. You can make it yourself, probably for about $200, a 3D printer.
Yep.
It's going to print in plastic, called PLA, which is like a cornstarch, a bioplastic. But I think in terms of taking it forward, it's going to be the younger generation that take it beyond us four can see it right now, based on our preconceptions and 30, 40, or 50 years of experience, of life experience. So it's that younger generation. If we put the tools into their hands now, which we are looking to do through the Fab Lab networks and through obviously a lot of schools, they'll take it forward in terms of completely new domains we've yet to conceive, I think.
Yeah, I think the issue is still, the UK was fairly, I think, forward-thinking how they introduced coding into the curriculum, though. The 3D printer that might have been bought by the parents or by the school based on a fundraising campaign still sits in the computer lab and is part of ICT.
It's like the Raspberry Pi. Google gave out a whole stack of Raspberry Pis, and we've got 800 in the lab in our cellar because the teachers, they break, they stop, they go in the box, they go in the cupboard. Teachers like consistency. They like, input, output, and outcome. Yep. And I think with a 3D printer, there's a knowledge issue that printing is, anybody can go to Thingiverse. Thingiverse is like a library of curated models that people have made. But the challenge is teaching yourself how to CAD, use 3D modeling and create that shape, that artifact, that bit on your toaster, that bit on your shoe, that bit for your cap, that for your bag. That's a skill. And that's, I think, the knowledge gap. If you don't get over that knowledge gap, then 3D printers just going to be in the house with a Thingiverse and print robots forever. And the question there is, are we creating machines that just produce waste and use energy in the process of doing it? So there's lots of different perceptions or different angles to look at this, I think.
Bram, what does your future look like?
I try to simplify the future always a bit. So 3D printing is a digital manufacturing technology. It's not the only digital manufacturing technology. There's also laser cutting, CNC milling, and I think digital manufacturing has an amazing future ahead of it. Why I think that is that the way we make most products today just doesn't make sense. It's very inefficient to get products from the other side of the planet, from Asia, get them with a container ship and a truck and a warehouse, get them to the end user, while there are digital manufacturing robots all around the world, and they still need some improvement. They're not perfect yet, but that could just make your product very close to you, and only after you place an order. So there's no more overproduction, and I think that makes sense. So I think it will eventually happen. How long exactly it will take, it's hard to say. My estimation is that in about 10 years' time, 10% of consumer products will be made with digital manufacturing technologies, and that's 10% of a $4 trillion manufacturing industry. What we're doing with 3D Hubs is we're trying to accelerate that future by giving everyone local access to those machines. So today we provide over 1 billion people in the world with access to 3D printers within 10 miles of their home. So it is happening. They're digital manufacturing robots. They just have to become better, and I think then eventually it will be a very bright future for it.
Cool. Tom, what's the future?
Well, I think I completely agree about sort of the distributed and on-demand manufacturing. I think the fact that so many of our products are sort of forecasted in demand, maybe a year ahead of time, and then sort of put in a warehouse for inventory. There's a lot of waste involved there. So if you can actually start printing things on demand when they're requested, you're saving a lot of wasted time and effort. And if you're automating it, you're actually there's a lot of inefficiencies that are taken about there as well. I think we're all about networking these systems together so that they can be more efficiently used and automated, so that they can be used literally on demand, not just from where you are, but directly from the manufacturer to the end location of the customer, especially for the manufacturing side. And I think that the education point is a big one too, because a lot of engineers coming out of school today, they're still used to designing parts for traditional manufacturing methods. So there's still a re-education needed for actually designing things for 3D printing and making that a lot more efficient. So actually training the next generation of engineers that this is possible. You can create things literally from the ground up, from the base material, instead of requiring big blocks of material and wasting all of that in the process.
Okay. So, any questions from the audience for the panel? Everybody's pretty shy. No questions last panel either.
Could I ask a question?
Yes, of course.
How many of you got 3D printers at home? 2, okay.
How many have 3D printed something for work or pleasure? Some.
How many people have printed a 3D stent for an artery?
I'll try
Not yet.
Yeah. So actually, the story I was telling you earlier on, so I was trying to teach myself how easy it could actually be, and there's a program from Autodesk called Tinkercad. Super simple interface. I grabbed a model. I literally created a model of my name. 5 minutes, hit the 3D Hubs button. The design, the actual CAD file got sent to Fab Lab, and they actually took the order and printed it, and I picked it up the next day. And I think I paid, whatever, $25.99. And that process took me 10 minutes end to end, and I never 3D printed anything in my life. Was it a social utility? Was it going to create any value? No, but it was pretty cool to actually realize how touchable actually this technology and the network effect is today. So last question, up and down the panel, 3D printing, hope or hype?
It's somewhere in the middle, hope.
Short-term hype, long-term hope.
Yeah, I think there's been a lot of hype over the last few years. That's over now. We're going through our trough of disillusionment. But that's actually when the most technological development's actually happening. There are amazing things happening now on the technological end, so I'm very hopeful. Yeah.
Yeah, I agree with Bram. I think we're sort of past a lot of the hype, and we're getting into the real meat of it and the hope of it.
Yep, I get excited about what the future lays, and I agree that the hype's been pretty crazy in the last couple of years, but the tangible stuff that we're seeing happening today makes it quite real, right? So,
And what kind of quick, if you want to print something, visit fablablondon.org. We're open on Fridays and it's free.
thank you for your time. Thank you guys. Appreciate it.
Thanks.